just having a look over the changes that's going to be introduced in Angular 14. And we're going to pass through the slides. And of course, feel free to interrupt me if you have any questions. I want it to be an interactive session. I don't want just to give you some information that you're going to forget about. So I'm going to start by sharing my screen. Please just ping me when you see my screen.
Okay, we see your screen.
Can you see it? Okay, great. Okay, so mainly in this Angular release, I'm going to just start by stating the main changes that were introduced into Angular, just in brief, just for you to know, to be aware about what we're going to be talking about in this session. So mainly the first thing introduced in Angular, which is a major change, is going to be standalone components. It has been a struggle over the years. I mean, I had a previous experience with React before I started developing in Angular. And when I started developing in Angular, I felt there is a lot of tight coupling between the components. That's because we didn't have a concept as standalone components, and we're going to dive deep into that later in the session. The second topic is that basically the Google developers were just reinventing the Angular compiler to be based on Ivy, which is in our modern development community, it's very advanced and it's considered to be much faster than it used to be in Angular, and it improves the Angular performance overall in web applications, and basically it resolves a lot of runtime issues that we used to face as Angular developers. So I'm just gonna be passing through the slides and I'm gonna be presenting them, and we're gonna have some look at some code, so so that we make sure that we grab the idea as is. Okay, so now I'm in full screen. I'm gonna be passing through the screens as well. So here we're gonna, first of all, let me say this. Whenever Google develops a feature or adds something to a framework that they already have, they usually test it in many other components that Google actually builds. So for example, when they transform Angular to use Ivy as their compiler, you have to be sure that they've done that with like Firebase, with what we're using right now, which is Google Meets, and they've done that with many components. So this is very important, that whatever big and major feature Google is releasing, they're going to be testing it really well, so that it's considered a just tiny release compared to the amount of testing they did. So as you're going to see here, basically Angular didn't just add new features. The team basically improved the compiler of Angular, which means this is something that we notice as software engineers and we appreciate, since whenever we add new features, okay, we're horizontally expanding our features, our utilities, and whatever we can supply to the developer. However, when we see a community like Angular developers developing the infrastructure of Angular, we see that they're really looking to improve the runtime process. They're really willing to improve the overall process for the developer himself. So this is not easy change. We have to be aware that this is not an easy change. I mean, when you rewrite everything, a compile-based Angular, it's not an easy change. I just want to highlight that. But as I said, this is well tested on all Angular components, all Google components that are basically web-based. This have been tested already. Okay, so I'm gonna start with the Ivy change that Google introduced. So the team rewrote from the ground up Angular's runtime and compiler. Okay, apps are now powered by the better, more efficient Ivy rendering engine. So when you talk about a rendering engine, it's basically what, of course, just let's touch bases right now. We want to be aware that when we're talking about Angular, we're talking about SPAs, so they're single-page applications, and those applications based on the route in the browser are basically rendering some type of component. Okay, so basically we only have one main page in an Angular application, and all what's rendered in it is just a component based on the route. Okay, so whenever we have a navigation stack, it is a stack. It's not just called a stack. It's a real stack. If you can imagine with me, if we, for example, used our phone and we enter the settings, and then we enter, for example, lock screen settings, and then we enter fingerprint settings. When we want to go back, we want to pop the last one in. So it's last in, first out. So for that reason, it's a stack. Okay. So when we say that, basically, the app is now powered by Ivy rendering engine. So whenever we render a component in, let's say, following a specific route in Angular, it's of course, as you know, again, it's just, we say it's pushed in the navigation stack. And when that is done, the component is rendered in the single page application. We never, or let's say, we barely see in best practices any page in an Angular application re-rendering as a whole. We don't do full page reloads. We just replace a component by another component. Okay, so Ivy offers numerous advantages. Basically, it improved type checking and error reporting. It has better debugging abilities. Additionally, it caused smaller bundle sizes and much more. And we're going to dive into that in the coming slides. But for now, let me just share some of Ivy's advantages that were introduced into Angular 9 even, not just right now. Okay, so I'm gonna just pass by them as documented by Google one point after another. As we already talked about that, we have now smaller bundle sizes. Okay, so if you have ever worked with Webpack, we all know that any Angular component at the end of the day is going to be compiled to a bundled JavaScript file. So I believe this is very important for Angular developers to know that Angular components are never really rendered in Chrome V8 engine or whatever Firefox engine as Angular. There's nothing called Angular. Okay, there's nothing even called TypeScript as with respect to the engine. The engine only understands JavaScript. Okay, so we have to understand that before us having the Angular application shown in our website or web browser, there is a compilation process happening behind the hood, and that happens through the V8 engine. And if you open any web browser and try to click and go to the console, and if you go to the sources, you're going to find bundle.js file. And if you've ever worked with Webpack, custom Webpack editions, you're going to have to deal with distributing these Angular files into custom JavaScript files based on your priorities. So what we're saying right here is that the bundled JavaScript file resulted after compiling Angular is usually with Ivy a lot smaller. So the bundle size is smaller, and we're going to talk about why that's important in a while. Just give me a moment. The second thing is basically we have smaller bundle sizes due to the tree shaking strategy that Ivy compiler uses. If you want to imagine that, whenever we want to use any Angular component and we import stuff that aren't related to that component and we're not actually using any of its utilities in that component, using the tree shaking technique that Ivy compiler use, it's gonna just alert us that, hey, you imported something you're not using. So this reduces a lot of unnecessary importing of libraries that's going to be heavy on the application. And one of the most critics on Angular is that it is a framework which is loaded with libraries that we don't even use. So that's one of the most important stuff that Ivy came up with. So the tree shaking technique is very important here. And when we say we're using Ivy, this means that we're using AOT. AOT is ahead of time compilation. It's not just JIT, which is just-in-time compilation. You got to be familiar with these topics. Just-in-time compilation shows errors in runtime. Okay, so for example, if I have a class, for example, and it's called student, and in this class we have two properties, for example, name and age. So previously in Angular, before Angular 9, we didn't used to have the ability to know if, for example, if you typed student.grade, for example, compile time, we're not going to know. So whenever we're writing the code, this is not going to give us error or underlined with red or nothing as that. We're just going to have a runtime error that is going to appear in our browser. And that's just-in-time compilation. I'm going to dive deep a bit in just-in-time compilation because this is really important to understand what's happening behind the hood. I'm going to skip pass the next sections in the presentation. It's not going to take so long, but it's very important for me to understand at least the core changes that Angular really made and that are important for us to understand. So let me just dive deep a bit in the just-in-time compilation. As I already described, we don't have anything interpreted in the browser as actual Angular. Okay, all is interpreted in the browser as JavaScript. So when how you're going to say, for example, right now, what's the difference between just-in-time compilation and AOT compilation? AOT compilation is ahead of time compilation. Okay, this means that whenever we're building an Angular application, all the errors are going to appear in our code editor or in our basically compile environment, as we call it, and it's not going to appear in the browser itself because we just compile our files inside the code editor before rendering it to the browser. Okay, so from here, I'm just going to say that just-in-time compilation is different. What we actually do is we literally send the compiler of Angular and the Angular files themselves to the browser. Okay, so this might sound ridiculous for some of you who has this information as something new, but this is what actually happens behind it. Whenever we're doing just-in-time compilation, like before Angular 9, all of that is being done at the browser level, and all of that basically is literally just compiled at the browser level. So any kind of build operations, errors are going to appear in the browser and not in the code editor. And this causes us a lot of issues. I mean, I used to develop and deploy Angular applications, and it's very annoying for us to check for example, you all know that between environments, environment variables are different. So whenever we deploy a change, let's say to staging or to production, it's very much easier for a developer to see the change or the error or the regression of the change that he made inside the terminal of the code editor. And this is what Ivy introduced. Okay, so instead of sending the actual compiler of Angular and the Angular files to the browser and letting the browser do the job and finding the errors whenever we deploy, no, we avoid all of that just ahead of time. That's why it's called ahead of time compilation. And while we're writing the code, for example, when I said we say student.grade, from now on, we have student.grade is underlined with red using the Ivy compiler. Now, this is very important for us to understand that it's not even at the TypeScript level. It's not a type. We're talking just Angular, okay? So we're not depending on Angular TypeScript typing, okay? So we're only dependent on Angular typing. And this makes a difference because, again, if you're not building your application using TypeScript, for example, you're using JavaScript, this is going to still be valid, okay? So Ivy compiler always, again, it's very much faster in runtime because of the small bundle size that it has, and it has better binding with the CSS files. We've seen this. If any of you did kind of testing which is automated on Angular components as unit testing, and you track the time and check the difference if we add the style sheet to the component versus not adding a style sheet to the component, you're gonna see a huge difference between binding with CSS model and versus without binding to CSS model. I mean, you're gonna be seeing like 15% change in time compilation. However, with Ivy, this is reduced to around 5%. Okay, so this is a huge and enormous change in binding with CSS styling. We've already covered improved type checking. We've already covered build errors and the build times since of AOT. And that is basically what I want to say about the Ivy compiler in brief, and we're gonna skip the coming slides for us to just have a look at them. Okay. Of course, again, with Ivy, we have the Angular language service. Basically, the Angular language service, you can dive. It has a really good documentation. You can see it. You can check it out. If anyone needs any references, of course, you can contact me on my links, and I've shared my email. The organizers can share it with you guys. So the documentation of Angular language service is really better than I can even describe. It's very, very much in depth. And the main idea behind this Angular language service is that I'm gonna just read the first line of documentation for you to just be aware and explain it a bit. The Angular language service provides code editors with a way to get completions, errors, hints, and navigation inside Angular templates. It works with external templates and separate HTML files, and also with inline templates. So if you're familiar with React, you're going to be familiar with ESLint. It's very similar to the Angular language service, and mainly it just improves the life of the developer by providing him a lot of easy and handy utilities. So I'm gonna just read what Google I/O provided. The team wanted to give developers even better integrated tooling with authoring Angular code, so they introduced the Ivy-powered Angular language service plugin for VS Code. It's an actual plugin that you can have in VS Code. It boosts developer productivity by providing type checking, syntax highlighting, and error reporting while writing code. This level of integration was only made possible by the Ivy compiler. So that's all I want to say about the Angular language service. And again, the documentation is really sufficient about that topic. This is one of the major changes that Angular did basically in this release, and Angular 14 state changes. So the dev tools, I found it to be really improved. I mean, it has many improvements. I'm gonna start by what Ivy provided us with to the dev tools. Ivy enabled us to build the Angular DevTools browser extension, giving the developers more detailed insights into the Angular application at runtime better than ever. I mean, we used to use, for example, if we had Redux integrated with Angular or any kind of centralized state management, we used to use their DevTools, the state management framework DevTools. Right now, we're not in need to use the DevTools for example, the state management tool that we're using. We can just use Angular DevTools, and they're just straight to the point. And they have integrated HTML illustrations, as we see right here. It's just easier. We can see in every page, in every component. It's of course, it's very important to know that it's component based. It's not like tag based like HTML. It's not like that. It's just component based. So here we have the app root, the app shell, and the UI side drawer. Inside it, we have the UI backdrop. Inside it, we have multiple links to several icons that are going to link us to whatever link is active in our Angular router. So that's in brief about the Angular DevTool improvements. We're going to go to the, okay, so this is very important thing that Angular has been discussing over the years, which is Firefox support for the Angular DevTools. I mean, we already introduced Chrome DevTools. So right now the team is working on introducing the same DevTools, kind of the same DevTools. There are always changes because it's not the same engine between Chrome and Firefox. But usually we like to have consistency in the DevTools, since the developer finds it easier, of course, to have consistent DevTools across browsers, since we usually test over all browsers mainly. It depends, of course, not in Internet Explorer anymore, but like Firefox, Safari, Google Chrome, we should be kind of bulletproof against all browsers and browser engines. So DI debugging is dependency injection debugging, of course. So it's as well improved. That's what I want to say. The way it is improved, I've looked at the changes that Angular are willing to do. It's not yet very clear, to be honest. It's just in preview mode yet. It's not just released. So when we release, we're going to have more insights about what are the actual improvements. But I imagine, as they were already discussing, the class base in Angular is going to be changed. So the way we inherit classes and the way we kind of implement interfaces is going to be a bit improved, which is going to be improving inversion of control principle, and in turn going to be improving the dependency injection and its debugging. Okay, so the dependency injection is going to be improved in the next release, and this is what we promised. Again, it takes a lot of time for Google developers to release some Angular features because they do testing over all the actual products of Google. Okay, so of course, as we discussed, it is faster with Ivy. We already explained that, and we're gonna just hop on like some actual numbers. In the future, in the next slides, we're gonna see like how the changes in the Ivy compiler really impacted Angular applications on different levels. We're going to see the impact of Ivy compiler on small applications, video applications, and large applications. So we're going to just start by stating that it is just thought in it. It's proven even by using the Ivy compiler in Angular-based Google applications that it used 90% less resources. So this is really, really important as we avoid, basically this is really relatable when we explain the standalone components of how Angular isn't anymore an imperative binded language. We're going to talk about that in just a second. Just give me a bit of time. So those are the numbers. We already discussed the smaller bundles because, as we told, that it is an AOT. So AOT just kind of avoids sending the compiler through the JavaScript bundle to the browser. So that's the major change in bundle size. Okay, so now talking about the ecosystem, of course, all of this is just infrastructure. Now talking about the ecosystem, one of the team's top goals was to provide an evergreen solution. And this was true for Ivy as well. So to accomplish this, they migrated the entire ecosystem with automated migrations to ensure they didn't leave any teams or their products behind. So this is very important from Angular that they're always like really caring for the backwards compatibility of the application, and they're even not just provided as they didn't even just provide us with command line commands for us to update the Angular application. They actually used it themselves while upgrading the actual applications that are built on Angular to newer versions, like version 14, for example. So we're going to have a look at those commands, and we're going to talk a bit about them. But they migrated the entire ecosystem with automated migrations to ensure they didn't leave any teams or their products behind. And the team was able to improve Angular without negatively impacting user or disrupting their applications. So they really avoided any regressions. And we usually see that from Microsoft, and we don't see it that much from Google. For example, right now, if you want to open the desktop and create a new folder, if you're using Windows, and you type the folder name to be capital L, capital P, capital T, and 1, for example, it's going to give you an error because that was a command in Windows XP, I believe, Windows 95. So yeah, this is how much these big companies are really backwards compatible. And this is very important for the developer himself not to change. This is always a principle that we always use in even when we're building such an application, such a small application, we use it, which is we always open for extension and we're closed for modification. So this is called an open closed principle, if you want it. So as I said, if you want to create a folder in Microsoft right now and we call it LPT9 or LPT1 from 1 to 11, it's going to give us an error, and even though we call it comp, and we have multiple commands that were used by the command line in Windows XP that are still backwards compatible up to this point. Not to avoid all conflicts, Microsoft committed themselves to be obliged with the backwards compatibility thing. So this is really important from Angular to see them that they're really caring for the backwards compatibility, and it's only enough for us to just run one command in our Angular application, and we're free to go, like literally just that. We're going to look at the command, and of course, if you want to benefit from the standalone components, we have to add some properties, and we have to change some project declarations and some, let's say, component declarations, but it's not going to be obligatory. So you can, on the fly, step by step, gradually improve your Angular application to be completely up to date. So this is really important. So now that Ivy has landed, they plan to continue building the future of Angular using Ivy. We're gonna move to the next slide, and that's what's next for Angular. Speaking of which, in order to serve most developers, the team have to create a simpler, more frictionless Angular for existing developers and those new to the framework. So this was always a struggle with the new developers coming to Angular, and even the Angular developers used to face issues when upgrading from one version to another. That was because they usually implement and deliver huge changes, kind of. Like if you look at the changes between Angular 9 and Angular 12, they're really big changes. And at the previous company that I used to work at, my role as a front-end engineer for their admin portal was to just migrate the application from Angular 9 to Angular 12. So this was really not that smooth, so to speak. So to say the least, yeah, it was really not that smooth. So they're focusing on that to make it really gradual process to update your application to the newest version. And even to the newcomers to the Angular framework, it was thought to be its big framework. We cannot just grasp it once at a time. So for that reason, we're gonna be seeing a lot of improvements at this level of Angular, in which just they made it easier on the developer to understand the minimal amount of information they need to start an Angular application. And one of the most complex stuff that was in Angular, basically, it was just the way the components are binded to modules. So if you've ever worked with Angular, you of course know the way you have to write a component and then bind it to a module. So I used to face that a lot myself. I mean, a lot of times I've used to declare some Angular components and I just forget to declare them in the Angular modules. So I have a component, but it's not actually binded to a module. And this caused me a lot of issues since basically I used to do the same thing in React. Like I used to write a component without binding it to anything and it just work. So why didn't that happen previously in Angular? Again, Angular is more of an imperative language. It's an opinionated language, or let's say framework to be more accurate. It's an opinionated framework, meaning that they really care for the developer to have a kind of systematic approach to write Angular applications. This is still true. It's still applicable. However, they made it gradual this time. So the prototype is not just a waterfall. It's just gradual. That's the difference. So, okay, coming to speak about standalone components, I've already talked about this interesting topic a lot. So, again, if you remember, an actual Angular component used to have a TypeScript file, SASS file, and an HTML representation of that, ng directives, if you want to say that, and it used to have one of the most important actual elements in it, which is the module, the Angular module of that component. For example, we used to see app.tsx, for example, if you're using TypeScript, or app.ts, let's say, and app.module.ts. So now we don't need the modules. So this is really important because it is just minimal thing for a new developer in Angular to just have a look on how to write an actual component and make it compile without worrying about binding it into a module and worrying about importing this module into the app module. And of course, you can imagine how this is nesting. This is nested through the each level. You go deeper in the Angular application, and let's say we have the main application component, and then we have, for example, the users component, and inside the users component, for example, we have the individual user component. So you can see how the trace is going in depth, and for each one of them we have to declare a module, and for each module we have to import it in the father component for that that sort of say component. Okay, so after the change of the standalone components, it's a new, simpler way to build components in Angular. Building component is a core part of the Angular developer experience. Right now, building components requires extra configuration. You have to create the component and then ensure that it's imported in the correct ng module. This means developers have to understand multiple concepts before building an application. Standalone components are designed to simplify application building and streamline the steps to getting started. Let's take a moment to investigate the new API. So let's have a look at the code itself. And here we see it's a TypeScript class. We imported multiple dependencies for our component. One of the dependencies is a component, the other is a module, and the other is a pipe. So for example, here we import foo component and the bar directive, which is a module, and then a bass pipe, which is an actual pipe. Okay, so right now, if we see, we have in our imports foo component, bar directive, and bass pipe. Okay, so we can also see that we have a standalone set to true. So this is the way to set a component to standalone, and we're going to talk about the difference in a while. So here we can see that we have the standalone property set to true, and we have the inputs set to the actual inputs in the current component. That's because the standalone component, we want to think about it. I mean, okay, the inputs in this current component are enough for the component to understand what it's going to use. However, because it's now standalone, when we want to use this component and another component, we have to know what are the actual inputs of this component. So if you don't know that this component, for example, used for component, and we use the component that we're now exporting, which is example standalone component, we use this class and another class, we're going to see that the Angular is not going to understand what happened exactly and what directives are missing. So for that reason, we still have to have full components, bidirective, and pass pipe in the imports. However, if you can see, we don't have any declarations, and we're not going to have any kind of module.ts. So this one property and moving all the declarations into the component imports and the metadata, it's going to like make us avoid all the boilerplate and all the extra code that we used to write in the module itself, in the module.ts, and it's going to be just standalone equal to true. It's going to be imports, setting all the imports to the actual component that we're building. And as I already said, IV compiler let us know whenever we have a missing directive or whenever we have an additional directive. I mean, whenever we're using an additional library, which is not necessary, using the tree shaking technique, it's going to be highlighted that it's not a necessary dependency to add. And if we're missing any dependency using the IV compiler as well, we're going to know that we need another dependency to inject. Okay, so that's in brief. I mean, by only using the this standalone true property and the imports, it's just ready to use as a standalone component in our Angular application. So that is really all of it. That's really all of it if we want to know about standalone components. So I just want to do a small recap about standalone components. I'm just going to restate how standalone components works. So we usually, previously, we're used to importing all the Angular components into actual modules. So we're going to have under the same Angular component 4 files. The first file is the HTML file. The second file is the Sass file. The third file is the actual TS file, which all the Angular logic is written in. And the fourth file is the module.ts file. So in this release, we're going to get rid of the module.ts file by just doing a standalone true property in the component metadata, and by just importing all the project dependencies in its inputs. So that's really all I want to discuss about standalone components. It's really still fragile and it might have changes in the future, but what's important for it right now is that it's really much easier to write Angular components. I mean, I've tried it myself, and I just don't forget any kind of module binding and tight coupling stuff. I mean, one of the main principles in our development world is tight coupling should be avoided. Whenever we have tight coupling, we should do a modularized approach. So what I mean by a modularized approach is let's imagine that we have two components, one parent component and one child component, and the child component is just rendered inside the parent component. Previously, as I said, in Angular, we had to import, firstly, we have to declare this Angular component, the child component, in its own module. And we have then to import this module into the parent module. So this was the process that we used and the approach we used in Angular. Right now, it's more modularized. I mean, it's kind of the concept in Angular that it's called SCAM, which is singular component Angular module. It's now virtual. So we used to worry about writing the module for this component, and now it's just virtual using the SCAM strategy. for each component, we have just a virtual module, which is automatically binded using, by the way, Ivy really helped here. If you look in depth, Ivy, I'm not going to go there actually. There is something related to Ivy and its way of communication to the JavaScript event loop and the VH engine in Chrome, which really made it easier for Angular developers and basically for Google developers to make Angular compatible with this kind of change, to have standalone components. So let's move. If you have any questions around standalone components, it's very important that you ask it right now, since you have everything fresh and ready, because we're gonna move to another topic. Okay, so I'm gonna move to a new topic, which is the enhanced Angular documentation and the enhanced way to start with Angular. So I'm going to read some of the IO input that they had. So there's more to simpler Angular story. The team is also creating an all-new modern getting started journey for developers new to the framework. So you're gonna, if you're used to Angular documentation, you're gonna see a totally new thing right now. So like within a month, a new total documentation is going to be released. And I had a look on the preview structure of this documentation, and it seems handy, and we're going to experience it. I'm not going to say that I have my final thoughts about it, but we're going to experience it in the coming months. So they're going to change the way they document stuff right now in Angular, because basically they had major changes which they needed to document anyway. So they already revamped all the way they're documenting stuff. This new guided path and documentation will include the most important Angular concept needed for developers to start building new exciting applications. The team is also making other changes to the documentation that will help to ensure that the content is a resource to the right path forward for your Angular journey. So it's very important that when you go to a documentation, you don't need to know a lot of boilerplate stuff and a lot of concepts which are really overwhelming, especially in our development world. You know, the technologies are just growing crazy and there are new releases every month or so. If you're familiar with multi-programming paradigms and even different programming languages, and you're working with different frameworks, it's really hard to stay up with the new technologies coming out without proper documentation, which is light. I mean, it's really important for the documentation to be light. I used to basically, I did a whole, in my current position at CME, I actually implemented a RabbitMQ as an intercommunication strategy between two solutions. I really got excited about the way they document the stuff in RabbitMQ. And it's not that user interfacing. And you know, Angular is much more used than for example, sort of say RabbitMQ. However, they really had great documentation, which made it really easy for me to pass along the path, and it was just smooth. So yes, in hindsight, had the versions of the Angular documentation been better in the previous ones, it would have been more or much easier, let's say, for the developers to get to know Angular more and feel that it is kind of easier to write code in Angular, because I often hear that React and let's say Vue is just much easier than Angular to start with. So of course, Google developers know that, and they're just improving the documentation. So okay, so now it's a very important topic as well. It's minor, but it is important. As I just told you, Angular is an opinionated framework. So by saying opinionated framework, it's more of an imperative language or framework than it is a declarative framework. So as we know, for example, compared to React, React is just a declarative library which gives the developer the utilities, and then the developer from there has the complete freedom to do whatever he wants with that. However, this gives the developer a lot of concerns related to the consistency between the React applications. I mean, if you move from Angular application to another Angular application, you're going to see that it's really looking the same. However, if you move from one React application to another React application, you're going to see that it's different. Okay, so Angular is still insisting to be an opinionated language and opinionated framework. I use language for Angular. It's not a language. Angular is a framework, front-end framework. So yeah, so they want the best practices to be defaulted in Angular, and even though they want the developer to have this kind of freedom, this freedom, they don't want this kind of freedom to compromise the best practice default that the Angular framework already has. So that's what they're saying. They're just trying to find a middle way between full freedom for the developer and for that imperative way of writing Angular. So the conformist is all about building in strong defaults and best practice to have developers build wonderful performant applications. The next initiative fits right in line with those strong defaults. Okay, so and that is typed forms. I mean, we all have used Angular and we all actually used some kind of auxiliary libraries and auxiliary dependencies in order to make our forms typed on an Angular level. Of course, again, I'm not talking TypeScript level, I'm talking Angular level. So the Angular team is actively building support for type forms and Angular templates. This is the #1 most requested feature, and they're close to making it reality. Developers will be able to build complex, even nested forms in a safe, backwards compatible method, which supports the incremental migration of your applications. As we already said, the upgrade of the application is going to be gradual, it's going to be incremental. So this is very important for the developer. What's more is that this feature leverages type checking as a best practice. So yeah, this thing was improved by Angular using TypeScript in the first place. So it's language-based utility, and now they're doing it at the level of Angular, in which we have typed forms. Okay, so that's all I want to say about that. Let's have a look on a small component in the basically, which illustrates how Angular framework itself handles type checking in a way or another. Okay, so here we can say that we have a const cat, which is basically a class or an object instance of a class, which is a forming group. And this forming group has two form controls. It has a name field and lives field. The name is the key, and of course, the Bob, which is Bob, is the actual value of this key. And the lives is another field, and the actual value of this key, which is lives, is 9. So when we say, for example, let remaining lives equal cat.value.lives.substring, we're going to see that the substring function is not going to work properly. That is because actually the substring is a method to be called on string types. And since now Angular knows that lives isn't a string format, it's just an integer or a number format, it's not going to be able to do a substring on lives. And this used to happen runtime because it was JIT compilation. Now, as it's an AOT compilation, we can know that it's going to give us an error before deploying or before even hosting the changes to the actual browser. So this is really important. And in the next line, we can see that it's set to be let cat email equal cat.value.email. And they're going to say that email is not a property on cat. So this error is going to appear. And then the last one, we're going to see that we're overriding all the values. Okay, the last one is a bit tricky right here because as you see, we're using object literals. We're opening the curly braces and then we're closing the curly braces, and we're passing the lives property only. And note that we have another property inside the cat class, which is the name. So here Angular is going to notice that, and it's going to give us an error saying that the name key is missing because basically we didn't even provide the name, which is an actual key in our class. This is really important, and it really makes it easier for the developer to find these stuff while developing the code. Here they just highlight the actual errors and why they happen. That's what I wanted to say about it. So just as we've seen, typed forms highlight potential problems with undefined properties, and with type checking, we can also expect it to catch errors with missing properties. This example demonstrates the issues that arise when the value of a forming group is attempted to be set within an object literal that's missing properties defined in the forms group creation. This is just the last example as I described. Okay, so now we're gonna move to another kind of topic in Angular, and it's going to be just the strength that, I mean, this really gave Angular strength, and we're going to just let's dive deep into it. Basically, one of Angular's core strengths is its ability to scale your development, your teams, and your applications. Just imagine how your experience with Angular will improve as these features and more land in the future, but this is only a small preview of what's to come. For now, let's talk more about the Angular, about Angular and Angular's future. So the main concept behind Angular, which separates it from other kind of libraries or other kind of frameworks, is that this framework is built for size. This framework is built for mass. So you're gonna see that these changes made to these, I mean, small utilities in Angular, maybe it's not gonna benefit medium applications a lot. Maybe it's not gonna benefit small applications a lot, but for sure it's gonna benefit big applications a lot. I mean, it's gonna benefit huge applications really a lot, because I used to see bundle.js files hugely decreased in size, and of course you can imagine how much errors we avoid using ahead of time compilation with Ivy and using some kind of standalone components, and it's gonna make the developer much more productive and avoid a lot of boilerplate, unnecessary boilerplate, which Angular can basically induct by context, sort of say. So that's what I want to say. Let's have a look at the slides and they can explain there. I'm gonna just skip this. Okay, so for solo developers, as I already said, for new developers, we focus on simpler Angular. We don't really focus about having the new developer having all the concepts in place before starting before starting to develop Angular application. The main priority for Angular developers when they start developing in Angular is just that they have straight pass-through to just try to write first application and just see it work, not see a lot of problems and runtime, or not see a lot of boilerplate code they have to understand. So for that reason, it's first-class CLI, standalone components, native solutions for common patterns like routing and forms was basically, there were a few of the major changes that made it easier for new developers to get really fastly used to writing Angular code. Okay, so as a solid developer, we want Angular to take care of the hard stuff, like as we saw here. We don't need the developer himself to bind the actual component into the module. We want Angular itself, like, kind of conclude through the context it's just not through the context. Of course, we just described how we're gonna do that using importing the dependencies and avoiding declarations. We're gonna do them in the import section. We saw already a piece of code illustrating that. So this basically transforms or moves some of the weight from the actual developer to the Angular framework. Okay, so this is very important for a developer to see that it's not that much like, there's not a lot of friction to write Angular code and have an application actually working. Okay, so talking about that, we have I Miss My Cafe, which is basically a very important kind of space, which is imissmycafe.com. It relies on provided Angular material components and built-in accessibility to go viral and provide a virtual cafe experience for over 1.7 lifetime users. Okay, again, the source can be shared, and it is just imissmycafe.com. It's literally that. So they have a lot of shared built-in accessibility utilities that Angular material components use, and there are a lot of contributors to it, and over 1.7 million users is already using that. So basically, now we're gonna see the impact of kind of the changes that were built or were delivered basically in this version of Angular on different sizes of applications. So as we see here, small teams are gonna basically see a benefit, which is in the built-in best practices, strong typing, and the PWA is, I believe it's already discussed in this meeting previously. So of course we have PWA and I18 and support. And this is for small teams important because it makes them like kind of avoid much more complex stuff that Angular now takes care of. Okay, so moving to the next medium level application, we can see that for teams just less than 100 developers, you're gonna see easy onboarding, strong debugging support, tested against Google's mono repository. So again, this is maybe the fourth time I talk about that everything delivered by Google is tested against Google's mono repositories. It's not just with Angular, it's basically with every other feature they use, okay? So, of course, this also helps in scaling our teams as we have large-scale businesses using Angular. For example, let's say Firebase are now going to want to upgrade their Angular version to 14. And let's say we have 100,000 developers working on Firebase, for example. So it's, of course, not that easy to introduce all of these developers to major changes. So the easy onboarding process and the gradual project upgrade is really handy for the developers themselves. And the strong debugging support as well is going to make them avoid a lot of errors while they're writing the Angular code. Moving to the next slide, of course, for large-scale businesses, we're gonna see consistent architecture, and I already described that. I'm gonna restate what I just described. I just said that Angular is more of an imperative language, which means that it tells the developer how he should write the code and how the code should be modularized. And in this way, when another developer comes to the team and he used to have Angular experience, he's going to feel familiar with the Angular code, regardless of the actual application itself. So because it's just prototyped and it's just following best practices. And this leads to consistent architecture. This leads to easier movement between applications and between modules inside an application, which is really important. And all the features that are introduced in this new release are just supporting this point of view. Okay, so now we're just gonna have a look at Firebase, which basically scaled to 1.4 million lines of code, maintaining high quality, of course. So, of course, as you know, Firebase is Google-based and it's built on top of Angular. So Firebase is the Angular at scale with over 1.4 million lines of code, while upholding high code quality with lighting and testing, while keeping build times low. This is very important to keep build times low. And of course, again, this is managed by Ivy and the restricted bundle sizes, if you want to say that, because again, it's really important to have linting while writing code instead of facing runtime issues, which basically makes the team as whole much more productive. So, yep, now we're going to come to the actual command that we write to upgrade our Angular application to the version 14. That's, of course, automatic, and it's migrated. It's not basic. It's an automated migration of an Angular application to the new version. And as I said as well, Angular developers used that while they tried it on all Google products. So let me just take a sip of water. I've been talking so fast. Okay. Excuse me. So the command is just ng update. It's that simple. No matter the size of the application, you want to provide a path to test. You want to provide a path to the latest version of Angular. The Angular CLI's ng update command unlocks the newest that Angular has to offer. Let's take a look at how team prioritizes the application updating journey and backward compatibility of Angular. Basically, many new features are no up. It's not an option to update them or not to update them, and they come out of the box as we type this command and we run it on our application. They're gonna come as no up, and they're gonna be automatically updated out of the shelf. And our goal is to deliver these changes with minimal transition cost. The transition cost isn't just, of course, it's not money cost, it's cost, time cost, it's productivity cost, it's this kind of cost they're avoiding. Okay, so update.angular.io maintains a record of our recommendations for how to move your application forward. So if you need any documentation on how to move forward with your Angular application and how to update your Angular application to be just compatible with the latest version, you can go to update.angular.io to have a look at the latest release documentation. And as well, it is really light documentation, as we already said that Angular is using that over all their components. They're trying to build live documentation for the developer and the new developers just to be really comfortable using Angular. So speaking to the future, now we're gonna be talking about some of the or sort of say what we see in the horizon of Angular. So the Angular team releases features as they're ready. This means that something revolutionary like standalone components, yes, a standalone component is something revolutionary. If you used to develop Angular applications with no standalone components, and now you have to write standalone components without even worrying about writing modules, it's really something big. But as I already told you, this change can be minor as long as it meets the regular testing and the rigorous testing and breaking the change requirements and using it in their actual products. So yeah, when they use it in actual products at a scale, it's very easy to say that it is really a minor change when we use it, because they're using it for Firebase, for example, and it's not going to be having a performance issue while we are using it in our daily jobs, because it's not as big as Firebase for most of us. So basically, we can talk about okay, let me say it this way. Angular wants to enable developers to build for everyone. In addition to in addition to our set of accessibility tools we offer together with the static checks and the component development kit, Angular's newest version will introduce streamlined management of your app's page title. So this is very important to know about. So the built-in router feature allows developers to define unique page titles more simply, tackling a common accessibility issue in web frameworks. Yeah, so this is a common issue, and it is really across all web frameworks, so to speak, because it's not easy usually to just use a custom unique page titles across applications and let the actual framework figure it out for us to what route this title belongs to. So we're gonna say it another way. Again, this built-in router feature allows developers to define unique page titles more simply, tackling a common accessibility issue in web frameworks. So now we have just a standalone, let's say, utility for Angular, which is the built-in router feature, in which we used to must use another framework, another library, another dependency to make us route easily. Okay, that would be many. I'm not going to dive deep into actual dependencies that I used to use in my daily job, but you have to care for the library maintenance. And when Angular itself introduces something as routes and routers, it's much more reliable and trustworthy. Okay, there is as well an extended diagnostics. So you can check that on angular.io/extended diagnostics. And this basically allows code editors to warn developers of common mistakes before compilation. This provides an extendable framework for continuing improvements in developer productivity. It catches when knowledge, let's say, for example, let me give you an example. You can understand it this way. Whenever we're doing nullable values and we're assigning it to a non-nullable value or non-nullable field, we're gonna find right now errors in the application. So we didn't used to find that. For example, if you assign a null value to a non-nullable field in Angular, this used to bypass in the actual. Basically, we didn't have ahead of time compilation, so we had just in time compilation, which didn't even see this kind of error. So I don't want to use a lot of your time. I'm gonna move just faster. Okay, so we have standardized arguments parsing. And this is the command line interface simplification. You can also look that up in the documentation. It's just that the command line parsing is having right now just better way of interpreting the errors and better way of describing the errors and better ways of just setting the correct stack trace of the error. So this is really important for the developer whenever he's having an error, to be able to know where exactly this error happened and to be able to just go to the exact line in which it happened in. This is really improved using the Ivy compiler and the new release of Angular. Okay, so now we're going to move to NG Analytics. It's a better way to control and print analytics settings. I'm not going to dive deep again. We're short on time. We have as well NG Cache, which is just as well a way to control and print cache information from the command line. Okay, we're finalizing right now. I just want to talk about the Web Dev Vitals, which is basically we're continuing to partner our innovation and exploration of the web. The team has had a wonderful opportunity to partner with Chrome's project, Aurora, to help Angular improve user-centric web performance metrics. So right now we have the LCP, FID, and CLS, which is basically we usually use commutative layout shift. And of course, we sometimes use other stuff, but you can go in depth in those. We have loading, we have interactivity, we have visual stability. You can dive deeper in that. It's a vast topic, which just we're gonna wanna mention, but this was as well improved. And it was a partnership with Chrome. So those are basically the main stuff I wanna discuss. And I'm gonna talk about just a little bit about hydration. Basically, we have currently something called destructive hydration. And the second part of this year, our team is gonna be spending a time on investigation and hydration. Their focus is on further improvement of the user experience and performance of apps and utilizing hydration to further innovate in that space. The team is committed to innovate the framework while providing backwards compatible experience. So make sure you follow them on social media and keep an eye on the RFCs. So that's what I want to guess. That's what I want to say. Overall, we're really having good experience with Angular. Basically, you can check the documentation of the roadmap to the future at angular.io/guide/roadmap, and you can share your feedback using the following links. And thank you all, guys. I know I talked so fast sometimes, but I just wanted to say all I wanted to say in just this short of time. So sorry for being fast, but I've shared most of the things I wanted to share. So if you have any questions, just go ahead and ask them. I'd like to hear from you.